Okay, so this is just to give you guys an extra shot, an extra chance at practicing a little bit before your big test. I've taken the review that I saw and just kind of made up problems very similar, okay? So let's start with number one. Okay, numbers one and two say use the limit definitions to find f prime of c. It might say evaluate. I don't know what it's going to say on the directions, but if you see this form, remember it looks very much like the limit definition of a derivative, okay, which looks like this. And so the way that I do these problems is I just kind of compare. And I know that, when I look here and when I even look here, the function that this problem used to be was the square root of x. Now, why did I write the square root of x and not the square root of 3? Well, 3 is just a number that's been inserted into my function. So that might be called the c in your class. So if you are asked, well, what's the numeric value? Well, that's the c, that's the 3, but you just sort of ignore it. So you ignore the h, and you know that the 3 is in place of the x. So once you figure out what that function is and you write it as an x and not a number, then you can take the derivative of that, okay, which remember this is the same thing as x to the 1/2. So the derivative would be 1/2 x to the negative 1/2, or you could write that as 1 over 2 root x. Those are both synonymous. And then this problem just wants you to plug the 3 back in. So it's like you take away the 3, write it as an x, take the derivative, now we plug the 3 back in. So I'm getting that as my answer, okay? Number 2 is similar, but it's not a limit definition like this. It's the other one. It's the one where it's pretty much just slope. It's pretty much just y minus y over x minus x. And so you do the same thing. You look for what is the actual function in this problem. Well, if it's a y minus y over an x minus x, it's going to have something to do with these numbers. And I only focus on what's in front of the symbol. Like this right here is probably my function, 2 cosine x, and then I take the derivative of that, which would be, let's see, the derivative of cosine is actually negative sine. And then in this one we have to identify our c, because that's what we're going to evaluate right here. Now, the way you find c on these is easy. It's always that right there. It's always whatever x is approaching. And in this case it's a pi. And then it just becomes unit circle. So let's see, the sine of pi is the y at pi, which is 0. 0 times negative 2, still 0. All right, cool. So hopefully that's getting a little bit better for you. Now, number 3, find the instantaneous rate of change. Instantaneous rate of change, that's pretty much just saying take a derivative but at a specific place. And so if you want to know what that specific place is, well, that's why they gave you a point back here, okay? So step 1, rate of change, I need the dang derivative, okay? So let me write the original just to make it a little more clear. And then I'm going to beg all of you, before you take the derivative, write this in a form that makes it friendly to take the derivative. So in other words, like this next term, this is not good. I would write that as x to the negative 4th, because you want it to look like, a polynomial, x to some power. Do that first, please. Then underneath you can have your f prime of x, or you could call this the dy over the dx, and then you do your derivative. So 1/3 x to the, let's see, if I subtract 1 from that, it'll be 3 over 3, so how about negative 2/3? Minus, now I'm going to bring this negative 4 to the front, so it's actually a plus 4, and then subtract 1 from that. And then this will just be plus 3, and then the 5 will go away. So this is your derivative. I'm just doing a power rule over and over and over. And this might be an answer choice, okay, but usually it's really ugly to leave negative exponents. So what I would do is I might take it a step further and take that x to the negative 2/3 and actually move it down into the denominator. Same thing with this one. Take that x to the fifth, move it back to the denominator. This is most likely how it would be written on an AP test. So not sure what your teacher will do, but this is how I would do it. Another option is they might actually take that radical, because right now this fraction exponent can be written as a radical, and they might write it that way instead. Okay, so seriously, y'all, like any of these three could be an answer that you're staring at on your paper. So just be familiar with the fact that you may have to do a little bit of work to get your answer to either match a multiple choice answer, or if you get, I don't know if you'll get points taken off, hopefully not, but if it's free response, then leave it like that. But if it's multiple choice, you'll probably have to do one of those, okay? All right, number 4, evaluate dy dx given that function. Okay, now when I see that function, there's two things that jump out at me. One of the things that jumps out at me is that I do see a product. I see some 4x squared times sine x. And the second thing is that I can't simplify this and make one of the x's go away. So like if there was a way to distribute or combine these, then you'd only have one x, then you could just use a power rule. But this is simplified. It can't go together. So when that happens, you need to really identify the fact that this is multiplication and there's two separate functions. I'm going to call that one f and that one g. And you've memorized your product rule, and you might have done like f prime g plus fg prime. That's probably how you've memorized it. And so that's what I'm going to do. So the first thing is I need an f prime. Feel free to take notes when you're doing these to make sure you don't make a dumb mistake. Because if this is f and this is g, feel free to go and figure out your f prime and your g prime. Let's see, f prime would be 8x. And g prime would be, let's see, the derivative of sine would be a positive cosine. Okay, so now I know all four things, and I'm just going to plug it directly into here. Okay, so f prime is 8x, and the g is sine x, plus my f is 4x squared, and my g prime is cosine x. And none of this can go together, so this is probably how your answer would be written if it's free response. Okay, FR, free response. If it's multiple choice, don't freak out if this isn't there, because somebody might have factored from the two leading terms. Like, see how a 4x can go into both of these? So if it's multiple choice, you would probably see this. 2 sine x plus, now we're going to take a 4x out of this. That's probably what you would see if it was multiple choice. So just, you have options. You always could look for simplification when that happens. Okay, number 5, take the derivative of blah, blah, blah. Okay, sorry. I'm trying to not go too fast. But if you need to jump around the video, I completely understand, because some of these may have been easy for you. And only really go back and listen to me if you missed it, okay? So we're taking the derivative of this. Now, if, we're going to play if again, if this had been the problem, notice I dropped the plus 1, okay? If this was the problem, I would just separate this. I would say 3x squared over x minus 5 over x, and then I would just power rule each of them. I would reduce, and then power rule. But since there is a binomial down here, since there's plus or minus something, these are two separate terms. And you therefore can't simplify it. You have two different x, and you're going to need the quotient rule. Now, when you do the quotient rule, this is how I've memorized it. I memorize it as girlfriend prime, and then minus, and then I flip-flop these. So friend girl prime all over girl squared. So I know that makes no sense, but I always remember girlfriend prime, because if I remember girlfriend prime, then I just know to do the opposite over here, and then this is always the denominator squared. So same thing I did before. What is f? What is g? How do I do all this? Okay, this one's going to be f, and this one's going to be g, which means that my f prime, we'll write it right here, f prime is going to be 6x, and my g prime is going to be 1. And now I know all 4 parts, and I'm just going to plug it in down here, okay? So what is g? 3x squared minus 5, f prime, 6x, minus f, which one's f? Oh, poop. I messed up. Haha, just kidding, everybody. Okay, g is actually the denominator, times f prime, 6x. And then minus my f, this is looking a little bit better, times g prime, which is 1, and then all over g squared. Cool. Now this, I don't know. I definitely would do a little bit more work because this can easily be distributed. So I'm just distributing this. This times 1, that's just this. So then I'm going to distribute this negative to both. Watch out for that because you do need to distribute the negative. And so this is going to become 3x squared plus 6x plus 5 all over x plus 1 squared. So if you need notation, just this is g prime because we started with a g, so either write g prime of x or you could do dy over dx. I'm a big fan of the prime. Alright, cool. So we're almost done. Yay! I know this is a long video, I'm really sorry. Number 6, I love these problems. Find a value for k such that blah 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 is true. Okay, so when I go to do number 6, I wish my eraser was larger. This is becoming annoying. Okay, when I go to do number 6, all I know is that this is f of x, and I know that I'm supposed to be finding k, like this is the goal, find k, and I know that f prime of 1 is supposed to be 3. Well, based on what it's asking me to do, I know my first step is to figure out f prime, okay? So f prime is just taking the derivative of what's above. So f prime, I would take the derivative. Now this is just a number, okay, so don't let it freak you out. I do the power rule. I'm going to bring the 2 in the front and then reduce the power by 1, so it should look like that. Plus, okay, this has a 1 on it. We're going to move the 1 to the front, so 1 times k is k, and it's now x to the 0, so there is nothing behind this, and then the derivative of 1 is 0. So this is the derivative, and now I'm going to do this. This is telling me in the place of x, plug in that 1. And so now I'm looking at 2k plus k, and that's supposed to be equal to 3. Well, what is 2k plus k, y'all? Well, that's a 3k equals 3, so k equals 1. Yay! So these are not too bad. You're just taking a derivative, plugging in the x, and then setting it equal to whatever it tells you, and then you'll be able to algebraically solve for k. Will it always be this pretty? Absolutely not. It's probably going to be a fraction, but we lucked out, and I made up an easy one. Okay, and the last problem. These are awesome, and I'm actually just going to draw on the one that I gave you here. And I recommend that for you too. Okay, so when you see these last kind, you just have to pay attention to slopes. In fact, the first thing, the easiest thing is to locate where the slope is 0. So if you had to draw tangent lines, then the tops of the hills and the bottom of the hills have a slope of 0. That's important because wherever you notice that happening, just drop down to the x-axis, and if you're supposed to be graphing the slope, well, the slope is 0 here, so I'm going to put a dot at 0. The slope is 0 here, so that's another point, and the slope is 0 here, so that's another point. So far for my derivative graph, I have these 3 points, okay? Now, what about all the stuff in between? Well, look at your slope. If you look at this slope, hopefully you realize that if you were to draw little tangent lines, that the slope there is positive. That's a positive slope. Now, is the slope positive anywhere else? Well, that's negative. Then it's going up again, so that would be a positive slope there. So wherever I have highlighted blue, okay, wherever I've highlighted blue, since the slope is positive, I need to graph points that are positive. So from here to here, I need positive numbers. And I know I'm supposed to hit this point at some point, but that just tells me it looks like that. Okay, and I didn't reflect it, I just said positive slope, I need positive y's. Here, positive slope, so between these two, I need positive y's, okay? So I don't want to connect the dots down here because those are negative y's. I'm going to connect the dots there, okay? Now I'm going to look at the rest of this. This is negative and negative. So wherever there are negative slopes, I'm going to need negative y's. See, I'm playing connect the dots, but following the graph above it. Negative y's from here to here. So that red graph is actually going to be quite nice. Now, how high and how low do these go? I don't know, and your teacher is not going to care. You just need to show that you understand the general shape of the graph right now. You won't need to know how high and low those go yet, okay? Alright, so hopefully that helped you out. Give me a text or something if you've come across a problem while you're studying that you need help out of. But that was a good little sampler from the review I saw. Alright, good luck guys.